Hey everyone, welcome back. This is video number 2 on my more epic DML system. Before I get started, I know that's a bit of a cringe name. I just threw it in on the first video and I'm just going to roll with it. So it is what it is, okay? So today I'm going to be doing just some basic tuning of the system. I'm not really worried about room treatment and room correction and things like that at this stage. They'll come later. What I want to do now is basically establish a good sound and a sort of good baseline to work from. So I've broken that process down into 4 steps, which I'll be recording in this video. First of all, I'm just going to run the panels by themselves, and purely by listening test, I'm going to move them around and try and find the kind of sweet spot, best location for those panels, which I can then use going forward for the rest of my measurements. Then I'm going to incorporate the subwoofers and work out the time alignment that I require. So obviously the subs are tucked away in the corner there. The panels in their optimum position, not sure exactly where that is yet, but it's likely to be out into the room a little bit. So of course the sound from the subs is going to take longer to get to the listening position, and I want to find out what that number is because I can put that into my DSP in the Hypex amp and align that better for better frequency response. Thirdly, once I've got the subs up and running, I will be playing around with the crossover, the frequency and the slope. So I think I'll start off with just a 200 Hertz cutoff, low pass and high pass, take some measurements, do a bit of listening, and then I'm going to play with that, moving it up and down and recording the actual acoustic slopes of those individual drivers, and then just trying to tease out what's the best crossover frequency overall. Lastly, I will be doing a more comprehensive EQ of the panels. So that's going to be hopefully sort of broad changes, just trying to get that overall balance right to get the best overall sound quality, bearing in mind that the EQ could well be different left and right because my room is a bit asymmetrical. I'm not going to go into a heap of detail about the room itself today. That will come later in the room treatment video, I think. But I will be measuring both, showing both left and right, and then EQing them individually to try and get similar frequency response out of each. And that'll be it. No doubt at the end of all of that, I will play some cheesy YouTube music, which a lot of people hate, and quite rightly. You may not be able to tell any difference, but there you go. That again is what it is. So before I start to ramble too much, I'm going to get into it and start playing around with these panels. Okay, here is the speaker position that I've settled on. I'll throw up on the screen some of the other locations that I tried just so you can see what didn't work as well. Now, right now you can see I've got both speakers towed in a little bit, and they are about 4 feet or 120 centimeters from the back wall, and that makes them about 80 centimeters from that cabinet there, or 70 centimeters from the cabinet, a bit over 2 feet. And that's an interesting point, I think, because people, particularly with dipoles, will say, bring them out from the back wall at least 3 feet, which is all well and good. But if you've got a huge cabinet that sticks out another 1.5 feet from that wall, you have to take that into account as well. If this speaker is there, it may be 3 feet from the back wall technically, but it's only just over 1 foot away from the cabinet, which obviously also reflects sound. So you know, basic rule is give them as much breathing space as possible. And I've found that to be the best position. So I can line them up anytime just by where they are against the rug in the corners there, toed in a little bit. And obviously I'll store them back in the kind of more flat position when I'm not listening, or when I'm just listening to TV or whatever. So that's really good. I did try them, as you can see on the screen there. I tried them wider than this as well. And at first, that sounds really good because you get this huge sound stage. But then when I moved them back in, I could tell that I was lacking a little bit of that center image with the wide configuration, particularly with tracks where the lead vocal is a real focal point. It just sounds better when you bring them in together a little bit. So just finally on this setup, I'll just move back a bit so you can see where we are in relation to the couch. So that's my listening position there. I know it's a bit distorted with this camera angle, but conventional wisdom says start with a roughly equilateral triangle between the speakers and the head, between the speakers and your head. And near enough, that's actually what I've ended up with, even though I wasn't aiming for that in particular. So there you go. Sometimes conventional wisdom is correct, I suppose. Pretty obvious, but there you go. So that's it. I'm going to use this position going forward. Next step is to switch on the subwoofers and then calculate that time alignment between the subs and the panels. So I'm measuring from the panel to the center of the subwoofer. And that is 105 centimeters, around 41 inches. 105. I'll just double check the other one. Pretty close. All right, so the speed of sound in air at 20 degrees, I'm just going to call that close enough, is about 343 meters per second, right? 343 meters a second. My panels are 105 centimeters in front of the subwoofer. Again, I'm just going to round that to call it 1 meter, 100 centimeters. So 1 meter. Therefore, the number I want, which is the delay I need to apply to my panels, will be 1 divided by 343. And with that, I get 0.0029. I'm going to round that up once more to 0.003, which equals 3 milliseconds. So now I will program into the DSP a 3 millisecond delay on the panels compared to the subwoofer. And we'll remeasure and see if we get any difference. Right, so actually I needn't have done all of that, because when you put in a delay number here, the software actually tells you the distance. So that's pretty close to 105 centimeters, or 1050 millimeters, 3051 US. Was that like nanoseconds or something like that, which equals 3 milliseconds. So I'm going to upload that and we'll measure again. So here's the 200 hertz, and the red is the original measurement. You can see we've got a dip here in both really, and then not much going on. And then when I apply the 3 millisecond delay to the panel, it gets a bit stronger. So the difference there is about 7 decibels, but it's pretty localized just to that area. I'm not even sure if that's going to be hugely noticeable. If we take off the smoothing, so maybe this tells a bit more of the story. So here's our 200 hertz, just near that peak there, which is the after measurement. In the red before measurement, you can see we do have this huge suck out at 190 hertz, which is completely gone with the delay, but then the delay has introduced smaller suck outs at 183 and 157 hertz. But again, like these are all really narrow. They only affect like a 2 or 3 hertz range in total. So I'm not actually concerned about them. I don't think they'll be audible at all. This improvement is better. It's over a wider range. So we've got 187. It's about a 25 hertz range that is improved around the crossover area by putting that delay in. So it's not nothing. It's not as significant as what I expected it to be. But hey, a win's a win. So for now, I'm going to stick with that 3 milliseconds and we'll proceed to stage 3, which is tinkering with the crossover, adjusting the slopes and the cutoff frequency. So there's going to be a bit of work in this next bit, trying different crossovers. I'm not going to narrate my way through every single permutation. We will have a look at the measurements later, and I'll talk about it when I've got them all on the computer to look at, which for me will be later, but for you will be in like 3 seconds, I guess. So see you there. Okay, so I'm actually going to gloss over this section a little bit. I've come to realize that there's actually quite a lot of detail to discuss here, and I just can't get it concisely enough to fit into this longer video. So I will make a follow-up video covering this crossover stuff in more depth. But for now, I'll just show you what I ended up with filter-wise. So looking at the sub channel now, and I've just got the single filter. Initially, I had both sides of this, so the sub and the panel, with a 200 hertz cutoff and a second order slope. But what I've found through measurement and listening is that it's actually better if I separate those out a bit, because what I was finding was that the actual acoustic slope that I was measuring did not follow these idealized electrical slopes perfectly, which really shouldn't be surprising when you think about it. So on the sub side, the slope was too shallow, whereas the panel was dropping quite sharply just after that 200. So it was probably naturally falling off anyway, and I was adding a filter to it. So it just wasn't really working very well together. So after a bit of tinkering, I've come up with this filter. So on the bass side, it's a second order low pass filter still, but I've moved the cutoff frequency down to 170 hertz. So it's just encroaching a little bit less into the panel's territory in this case. And I've found that the bass has a little bit better definition when actually listening to music like this. I suppose there was just a little bit too much crossover in that region, and there was too much interaction between the panel and the subwoofer. So I've cut that down a little bit. On the panel side, I actually increased the cutoff frequency slightly to 210. So there's a 40 hertz now separating the two cutoff frequencies. And again, it still has the second order slope, but I've changed the Q on this filter to 0.9 up from 0.7, and I'll just change that back so you can see the difference. Okay, so that's dropping away on your second order slope, but like I said, the panel was dropping, I think, harder than that. So just by changing this a little bit, I have pushed this slope downwards in frequency a little bit and added this bump here. So this area was lacking a little bit. As I said, the panel was tending to drop off a little bit too early. So just that tiny little bump, I think, has improved the overall crossover area. Okay, so switching to the measurement now, you can see this is the 200 Hertz initial sort of crossover area. I mean, the whole thing still looks a little lumpy here, but this does blend in pretty well, right? You've got a nice slight overall downward slope. Remember, this measurement is taken at the listening position, so a slight downward slope is somewhat desirable. It's still kicking up a bit at the end here, and I'll deal with that in the EQ section later. But overall, pretty good. And I think those little tweaks to the crossover have improved the listenability, added some clarity to that kind of mid-bass area, which is great. So that's what I'm going with for now. Overall, it's not too much different from where I started, except as you've just seen, I've pushed down the cutoff frequency on the sub, slightly raised the cutoff on the panel, and changed the Q on the panel. Nice smooth frequency response when that's blended together. And I do feel that the bass just has a little bit better definition now than it did with the original crossover. So I think the main lesson for crossovers here is that you can't just stick in, a second order here and a second order there and call it a day. When you're setting those slopes in software or just via some kind of calculator, if you're doing passive crossovers, it's only telling half the story. That's the electrical slope, basically. So the actual acoustic slope is going to vary a bit, and it's depending on things like the natural fall off of the driver, or the natural peaks and dips of the driver have to be taken into account as well. So in this case, I think the panel was falling off around the crossover frequency anyway. So adding that bump thanks to the higher Q kind of smoothed that out a little bit. At the same time, the subwoofer, the slope was a little bit shallower on that one, even though they were both second order slopes in the software. So I've achieved a bit more kind of separation by dragging that down a few hertz, or 30 hertz, and achieving an overall more pleasing effect. So of course you start with that kind of idealized version, but then you really do have to measure, listen, test, and iterate on that to get the best results. And I'm not saying I have the best results, but I've got results that are good enough for now. No doubt I'll dick around with it more in the future, but I think it's sounding better than it was, and it's time to move on. So we've come to step 4, which is like a broad EQ, or broad EQ filters to be applied to the whole frequency range. So on to step 4, which is just to apply EQ, fairly broad EQ across the frequency range. And I am also going to EQ the subs a bit. I want to put out more low end. So if you remember my videos last year, since then I've upgraded my amplification. And when I did the relatively small sealed box, I said I'm going to make up for this with EQ and boosting the bass frequencies. So I'll be looking at that now as well. Okay, so the next step is to apply some broad EQ. So I'll start with the bass region. My big issue really here is the massive suck out at like 83 hertz. That will be a function of the room. You can't just throw more power at these. Like you'd think just a really steep and powerful filter might kind of plug that hole, but not so. The more power you throw at it, the more power is going to get sucked out by cancellations. So not really going to work. So I'm just going to leave that for now. What I want to do is extend the bass down to sort of 30 hertz region. You can see at the moment we've got this big peak at 40 and then it drops off really hard. So what I'm going to start with is this filter here, centered around 28 hertz with a Q of 3, which dictates the slopes here, and then an 8 dB gain. So the big problem or the big worry here will be that it also boosts this peak. So I may have to adjust that Q to avoid doing that. So for now, I'm going to upload that, remeasure, and then see how it looks. Okay, and here's the result, the previous measurement in red and the new result in blue. As you can see, it has made a big difference on this last part of the frequency range, down to, this peak is now 29 hertz. Unfortunately, it has also raised this peak here, which I did not want, obviously. So what I need to do is go back to here and edit this filter to make it narrower. Might even Q of 5 and see how that works. So the new plot is in orange, that one there. You can see it's made a little bit of a difference, but not much in bringing that peak down. So what I'm going to do is try and massage it a different way. I'll bring the center down to 25. Keep it nice and steep. And I'm a little wary about getting too deep here, so I'll just make it 6 decibel gain and remeasure and try again. Okay, so this is a little better now. Blue is the latest plot. You can see I've managed to bring the peak down and extend the bass out. This is 20 hertz down here, so that's pretty low. I don't mind at all that it's like tapering off at that point. So how I achieved that in the end was with this quite ugly looking set of filters here. So we've got the boost, 6 decibel boost at 23 hertz center frequency with a Q of 5. And then to bring down the peak, I've got a really narrow Q9 minus 6 dB centered on that 43 hertz, exactly where the peak is. And then this filter here is the crossover slope. That looks better there. As I said, I'm not going to worry too much about boosting all of this other stuff. If we have a look at our psychoacoustic smoothing again, it's starting to look better, right? Again, that's something to investigate later. Whether I need to have a third sub concealed somewhere, we'll see about that. We'll see how much I care, if it bothers me in the future. Okay, so that's fine. Let's move on to the panel. So far we've just got a single crossover filter. If we go back to our last test here, again, at that kind of level, it's pretty choppy. As I said, I only want to make broad corrections here. I don't want to get too nitty gritty about, oh, bring this, boost this, pull this one down, and all that. So what I'm going to focus on, at least initially, is I'm going to smooth this quite a lot. And then I'm just going to look at the general trends, right? So really we're looking at above 200 hertz now. So how to smooth this? Well, I think I'll put a boost at around 460, maybe 3 dB or thereabouts. And then I'm going to pull down from around 1K cut of around 3 dB and make that a nice broad one. I'll make them both nice and broad and just try and even this section out for a start. So back to filter design. First one was around 460. So 1, 2, 3. It's going to be around there. A Q factor of 1, so nice and broad, and then a 3 decibel boost. So that's what that filter is going to look like. And then the second one was at 1K. You can see that's this filter is so broad that it's actually reaching to 1K. So I might just back that off. Make it Q of say 1.8. Well, let's run with that for now. And then at 1K, add another filter. And this time it's going to be minus 3 decibels, also with a nice broad, like that. So I'll upload this and do another measurement. Okay, time warp. Skipping forward a couple of steps, I have added a series of broad filters to the panel here, as you can see. Now, this obviously looks really ugly. This is not the measurement. This is the combination of filters, and the scale is different from the measurement. So looking at the eventual measurements, this is what I get. And this is with psychoacoustic smoothing still. Really gentle kind of downward slope. Suspect there might still be a little bit too much top end here. It might sound a little harsh. So I'm just going to add one more filter to tame that a little bit. And then I will switch over and take a measurement with these settings on the right speaker and use that as a baseline to sort of tweak it as required. So here we have the same filters applied to the speaker on the right, and that's the one next to the opening in the wall. So I'm not too surprised to see that the bass is down. At 125 hertz upwards is roughly the same, and I don't think I need to make any changes to the panel up here. So this section through here, from 20 hertz up to, call it 75, there's between a 4 and 5 dB difference. So maybe around 50 to 55 hertz. Add another boost on the right-hand channel just to try and get those more similar. So save that as left, and then come back to here. That's at 43 hertz. Yeah, that's down there. Definitely want something higher than that. So maybe I'll move this one. 55. Just make it, let's say, -2. So effectively raising the output compared to the other side. And we'll make that a bit broader. A Q of 3. I'll upload this onto the right-hand side and see how we go. Well, that's a bit better. Okay, so with those tweaks to the filters on the right channel, this is what we get. And I've got to say that's good enough for me for now. They don't have to be exactly the same, but they should be similar. Remember, this is all in-room measurements from the listening position. So this takes all room effects into account at that spot. So with that in mind, I've got to say I think this is a pretty good result. Haven't listened to it yet. This is just based on measurements. Going to throw it on for a little while, listen to a bit of music now, and I will report back and let you know how it actually sounds.